Thanks for having us. Brad Schmidt, work for the State of Colorado Fire Agency in the Research and Development Office, and joined by Sean Triplett with the U.S. Forest Service, working out at NIFC, National Interagency Fire Center. And we'll be talking today about wildland fire and TAC, basically talking about how we've been piloting TAC as a location tracking platform and getting into providing situational awareness for wildland firefighters, and kind of where we're looking to go in terms of scaling that up from being a pilot project to being enterprise scale. So, diving in, to say that our level of situational awareness varies when we respond to a fire is probably about the same as saying that varies during a military response overseas. I mean, there's just everything from knowing exactly what's going on, confirmed by multiple aircraft and ground sources, to having someone say, I think I saw smoke 8 hours ago up on the horizon. So, but to talk about what we see in a lot of the western U.S. in the more rural areas, it's pretty common to see something like this. And this is actually a screenshot from our CAD application for wildland fire, computer-aided dispatch. And what I want to kind of point out here is that every time you see WAG, that stands for wild ass guess. So that is the dispatch basically saying, a rancher called us, they think they see smoke in this general area. That might have been a couple hours ago, that might have been yesterday even. So that's a pretty common thing, unfortunately, for us. We're starting to get into some new things. FireGuard was mentioned. When we do get FireGuard product, every 10 minutes now we can actually get a polygon from the National Guard showing where heat is being detected. That's an example of what that looks like from the Cameron Peak fire in Colorado. We don't always get that information though. Really the upshot of all this is that when we're dealing with new fires, emerging fires, typically we are getting pinpoints on the map. And this is actually a screenshot of a federal fire dispatch center. They're literally putting those pins on a magnetic wall-sized topo map. So we are truly using Vietnam-era technology today when it comes to wildland fire response. Always the question is, when do you get a map of the fire? If a fire is not put out, if it gets beyond that single tree that was hit by lightning, that type of thing, we're typically going to get our first map of the fire 24 to 36 hours after the fire starts. Once the cavalry starts to show up, we get an incident management team on scene. So when that team does show up, they bring a lot of resources with them, everything from caterers to feed the firefighters, communications to get radios working, all that fun stuff. They also bring mapping technicians that can start to produce those maps. So typically the way it works on wildland fires is that at night there are aircraft that are operated by the U.S. Forest Service that are flying all around the western U.S. They have an infrared line scanner, so they can very quickly map the heat signature of a fire, send that to an analyst who interprets it and creates a GIS product. And then the mapping techs on each individual fire can use that to make a map showing where the fire is. We push that out at morning briefing. Great, the guys get a map of the fire, go out into the field, and then of course by the time they're out fighting the fire has evolved and changed shape. So that is an issue. Throughout the day, kind of like what AJ was talking about, being a FOBS, a field observer, we have folks out running around collecting everything from where the helispots are, where we're landing helicopters, where we're dipping water, all the way up to where the fire lines are, whether they're cut by hand or bulldozer, that type of thing. Again, that usually gets physically driven back to the command post where the mapping tech uses that to make the next day's map. It's a pretty slow process. We are starting to kind of modernize it in some ways. We're getting additional aircraft beyond those night flying aircraft where we can start to map fires during the night and the daytime, so we can get a perimeter showing the fire's growth when it really starts to explode during the afternoon. So we're starting to get into that realm of having a real-time picture of what's going on a fire. We're integrating that all into ArcGIS Online. I'll talk a little bit more in a minute about how we handle that data. Yeah, that's all well and good when you're at the command post, you're maybe have access to a laptop computer, you're in an area with good comms, that type of thing. that typically goes away when you leave the command post and actually get out onto the fire line. You're out kicking dust with your boots, trying to fight the fire. You're typically solely reliant on whatever map product you brought with you, whether that's a paper map, or sometimes we do have access to Avenza maps, as AJ was saying, where you're actually able to get the day's incident map loaded onto an iOS or Android phone. You can take it out into the field, and then you can see a blue dot overlaid on that map for your current location. You don't get the location of anyone else, just yourself, but that's really the gold standard right now for situational awareness when you're out on the fire line. Other than that, we're really reliant on our analog VHF voice radios to communicate with each other, establish and maintain situational awareness. So Sean, I think I'll kick it over to you to start to introduce the Dingle Act and efforts to modernize this.
Good. So the Dingle Act was passed in 2019. It had about 10 components for the wildland fire agencies, and the one that we're working on this summer was the Congress and the President directed the Secretaries in Interior to go out and track wildland firefighting resources. Never defined what a resource was. It never really gave any direction, and the biggest thing above all of it was an unfunded mandate. So go out and implement a very large programmatic enterprise system to track wildland firefighters with no dollars attached to it. One of the big requirements we had was to conduct 2 pilot programs. So that is where we've reached out to Brad and the Colorado Center of Excellence and brought them in from their technical expertise. We pulled together an interagency team. We were chartered under both of the secretaries, and we completed 5 pilots this year where we went out and evaluated TAC and other tracking technologies. Now, one of the things that the Dingle Act, when we immediately responded to all this to Congress, is we know this is not a technology issue. We know the technology exists. Blue Force tracking has been around forever. What we really focused on this year is how, when we implement this tracking system, how are we going to do that from an interagency standards perspective? That's what makes fire really strong. Is I can pull an engine out of Florida, ship it to New Mexico, and it can sit there and work right next to a New Mexico engine, have the same comm setup, have the same hose and all the interconnections. We need to do the same thing with technology. So that's what we focused on this summer. TAC has some great interoperable capabilities. Esri's getting there with interoperable capabilities. We were looking across that platform. And the other thing is at last count, when you look at resource ordering, so who can actually provide a resource to a wildland firefighting? There's 608 listed agencies across the country right now that have the capability to show up with resources on a fire. So the perception that the Forest Service and the Department of Agriculture or all the agencies in Interior are going to go and say, thou shalt use this system when you're on fires is a very small chance. The other thing you have to think about when we're doing tracking is, unlike the military, when you enlist, you become, or as an officer, you become property of the government, we're civilians. And a lot of our unions have very strong privacy rules that have to be considered, even within the federal agencies. So we did evaluations on those too. So like what is considered privacy thresholds and that. And then the big thing is we're federal agencies. So one of the things that we've been evaluating with this is maintaining a culture of safety, and bringing in the data, storing the data, having the data available for post-analysis, and then also having that data available real time and partitioning out the data. One of the things about fires, especially when you're in a tactical operation, not all that data is available to everybody. It depends on who needs it and how they're going to partition it out and use it. So looking at different ways when we bring this tracking data in, so you don't overwhelm everyone. One of the first things that I remember when we did tracking is we gave devices out, the ops guys looked at it and said, there's a lot of dots on the map, and walked away. That's what we want to prevent. We don't want to have just a lot of tracking information. We want to have that information turn into actionable intelligence, something that a decision maker can use to make a decision. And so that's what we focused on. The whole pilot this year was not really focused on the technology. We're going to show you a lot of gee-whiz stuff up here, but really what it was is how can we make this interoperable? Because my responsibility all this is I'm going to have to take all this data and I got to put the investment plan together to go up to Congress and say, we want to do this because all the agency leads have already said, yes, we want to do this, but this is what it's going to cost. Yes, tax-free, but servers aren't free, people aren't free, standardization isn't free, deployments aren't free. Those are the things that I'm I'm responsible for working at NIFC. So that's what we did. Biggest thing there, all this is, again, subject to appropriations. Not to do the little silent violin here, but the infrastructure bill, there was money in there to make this happen. And then when Congress cut it from its original to its lower, all of that money was removed. So we still don't have any of the funding to do this. We were pretty excited. Looked like we were going to be able to get it, do some contracts and staffing, and then when they signed the bill and released it, all that was removed. So I spent this morning on the phone with OMB saying, we hear you, but you're going to have to fund it. And so hopefully they get the message. I'll turn it over to you.
Sounds good. So as we started this pilot project process, knowing that we had to kind of do things on a shoestring, Sean was kind enough to basically get us some funding through the Forest Service agreements to state governments to start up this pilot project for TAC. So what that did is it kicked us some funding to do some actual field support, which we did in the summer of 2020 as well as 2021. And then it also gave us some funds to start up a pilot project TAC server. It doesn't have all the bells and whistles that we know are out there from FBI and others, and we're really excited to expand that. But it was at least a good place to start. And the really important thing is we were able to integrate that TAC server with other data feeds and start to create that common operating picture that cuts across technologies. So you'll see the little green Jeeps in here. You're going to learn all about how we got those green Jeeps in and out of all the different systems we used. So in 2021, we tested 3 different tracking systems as part of DART, which is Dingle Act Resource Tracking. And really the idea there was to start getting at how we would create an interoperable system that can reach that enterprise scale, where we have multiple different types of tracking technologies that can all interoperate and create that common operating picture. So the first one up top was the Garmin InReach trackers. So these are just little, handheld devices that have a GPS chip, and then they communicate over the Iridium short burst data network. So we're able to get the locations out worldwide. We weren't pushing any data in. These were basically just passive trackers where you can clip them to some guy out in the woods and you can see where he's at. Of course, the TAC app, specifically the ATAC Android flavor, was what we used out in the field. We did primarily use FirstNet service. We had some BYOD folks, a lot of them courtesy of AJ, where they were coming in with other commercial LTE services. But we had a cache of 30 phones from us, and I think we probably ended up at 50 or 60 phones total. The Department of Interior FirstNet pilot project also provided us with some devices. So we were able to field TAC that way. And then the third system that we brought in were these basically automatic vehicle location devices that are fielded on Bureau of Land Management fire apparatus. So every BLM fire truck, hotshot crew buggy, and supervisor vehicle, pretty much all of them nationwide, now have this device. It's made by Orbcomm, and my understanding is it uses both cellular service and Inmarsat satellite service to track the vehicle's location anytime that the ignition of the vehicle is on. So we were able to bring that in as well. So how did we integrate all this stuff together? So this is basically the flow of the data. It's separated out into 3 categories. You have the field up top, and then how the data is processed in the cloud, and then how we actually disseminate it out. This is kind of small potatoes stuff, but I like to think this is kind of a kernel, hopefully helping to inform you guys on how we could scale this up someday to accommodate, multiple different types of feeds and integrate it all together. So we have the Garmin InReach, the BLM vehicles that are basically talking over SATCOM, and then the TAC app that's talking over FirstNet or some other cellular service. That is all sending data into the cloud. And the Enterprise Geospatial Portal, or the EGP, that's kind of our legacy common operating picture that's used in wildland fire. It's hosted by a company called Intera that I'll talk a little more about. And it is basically serving the data into a big ArcGIS feature service that hosts all the data. So in the case of the satellite communication devices, for the InReaches, we had a company called Everywhere Hub. They integrate the Garmin devices and provide the data as a single feed into EGP. Something similar happens with the BLM data to get in there. For TAC, we had Intera, our contractor, stand up an EGP TAC server. This is just a standard off-the-shelf TAC server. I think it's running 4.4. And then Intera wrote some code for us on a one-off that every 2 minutes bidirectionally exchanges data with their centralized tracking database. So if you're connected to the TAC server, your location is brought into the EGP database. And then the data from these two feeds for the Garmin inReaches and the BLM vehicles is brought into the TAC server. That is then rendered on the TAC clients as the little green Jeep icons that you'll see. And likewise, data from TAC is able to flow into EGP and then be displayed in multiple ways. There's a baked-in viewer for EGP. We also built a common operating picture that's based on ArcGIS Online to display the data that way. We kind of realized early on, especially on the EGP, it has a bit older user interface, and it was just kind of a sea of green and orange dots. So we kind of realized that we needed to provide a little more symbology and capability with the data there. So ArcGIS Online was an excellent tool to do that. With that, we were able to symbolize the data. So this is a screenshot showing that common operating picture that we ended up building. We have the TAC dots are symbolized by little tiny TAC icons. And then the BLM dots were a miniature BLM logo. And then if we had the Garmin inReach devices, they had a different symbology as well. We were able to do some scaling based on the age of the report. So if the reports had come in the last 15 minutes or less, they were a large icon, kind of like what you see right there. And then if the reports were between 15 minutes and 24 hours old, they shrunk by size by 50%. So that's the smaller icons there and there. And then we were able to use, ArcGIS has a JavaScript-based language called Arcade, where you can do some kind of low-code expressions. And they were able to basically provide, Intera was able to provide us a timestamp. I used that timestamp to symbolize how old the data was, just in plain English there. So your standard fire manager that's not wanting to see Zulu time and stuff like that, they're stressed out enough as it is. They can just look at this and see how old the data is in plain English. And then the key thing too is that we can bring in a lot of other data sets in ArcGIS Online. There are about 20,000 wildland firefighters have access to this NIFC ArcGIS Online organization, and they can, as long as they're trained to do it, they can use apps from Esri to drop points, lines, and polygons when they're out in the field, and that's all synchronized immediately into a national service. So in this example, you see a perimeter for the fire that was either hand traced by someone or maybe it was collected by an aircraft. We're also able to get the polygons from FireGuard. That's our collaboration between the Forest Service and the National Guard to map fires. We're able to get that data in as well. And then finally, dispatch information on the fire. That little dot there, if you click on it, we can tap up to, I think it's like 140 different attributes of data on the fire. So everything from where it started, how contained is it, all the way up to how many personnel are assigned to the fire. So very rich data, and this was a really popular way to view it. For folks that weren't tactically engaged on the fire, maybe they were back at command post, or they weren't needing to see every twitch and move of the TAC app users. With this information, they can see the general location of the firefighters, as well as this host of other data on what's going on. So kind of a little potpourri here before we get into our pilot projects from this last summer on other things that we've built under the auspices of this project. So IAA aircraft, it's the kind of civilian flavor of ISR aircraft. It's incident awareness and assessment, aircraft. So same idea, we have both rotor wing and fixed wing aircraft with gimbaled cameras that we're starting to see more and more on fires. And as you saw from Ian's excellent video, we're able to bring TAC data in and out of these aircraft using multiple different vendors' systems. So Ian was using Aero computers, and then we're using Churchill navigation computers in this example. But either way, you can bring data in and out. And so what you're seeing in this video is actually a time lapse of our state of Colorado multi-mission aircraft. It has a Westcam MX-15 sensor and the Churchill navigation mission computer, and it's integrated into the EGP TAC server. So as the aircraft is mapping this emerging initial attack fire, we're able to see in real time its position and where it's looking. Unlike Ian, we don't have the bandwidth as we fly up high to pass live video down, but we do have a AirCell kind of slow internet connection, and we're able to pass this cursor on target information showing the position of the aircraft and where it's looking. So I think between that and being able to talk to the aircraft on voice radio, if I was a firefighter on the ground and I was worried about something, I could communicate with the aircraft, have them take a look for me, and then they can describe to me what they're seeing, if the fire has thrown spot fires out ahead of it or slopped over a road, that type of thing. So we're really excited about this capability. To take it a step further, the sensor operator in the back of the aircraft can also see what's going on in real time relative to the TAC server. So this is an example from our mission computer, Churchill Navigation, where we're looking at an initial attack fire in western Colorado. And as the camera zooms in, you can actually see a dot both on the map here as well as in augmented reality on the video overlay for where a TAC client is. The cool thing about this too is that it's not just limited to the TAC clients. The Garmin inReach devices as well as the BLM vehicle trackers are also showing up in this mission system. So we've had some examples where our sensor operators have seen BLM engines driving around during initial attack. There's one case where there were multiple fires, and our sensor operator was able to monitor some BLM engines that had to start reversing and backing out as fire activity was increasing. It wasn't a life safety, emergency type situation, but it just gave everybody peace of mind to know that these engines were moving in the right direction and were staying, well out in front of the fire. So I'll pound the drum for ADSB a little more. Again, big shout out to Greg for building this code. This is something we're really excited about. So we are also standing up ADSB sensors, and we deployed sensors on multiple wildfires this summer, where we are basically building a Raspberry Pi based box, about $100 in off-the-shelf parts. We set it up at a radio repeater site and feed data out onto the internet. ADSBexchange.com, they aggregate all of these sensors. There's about 6,400 of them worldwide. So in addition to the sensors that we stand up, we're seamlessly tapping any hobbyist sensors that are available as well to cover an incident. And then we feed that data through Greg's script, which basically converts the data into cursor on target. We can also filter it, so we can get rid of all of the commercial airliners and things we don't want to see and just have a ramp list of wildland fire and public safety aircraft. And then we operate a TAC server. So this is currently a second TAC server that our TAC clients connect to. We're working on starting to federate that data in one-way federations into our operational TAC servers. We've done that on an all hazards TAC server that I'm running for the state of Colorado. So our search and rescue volunteers and folks like that just connect to their normal TAC server, and they see these aircraft points as basically another layer on that server. So we're looking to do something similar on the federal wildland fire side in the future, but something I'm very excited about. We're actually looking to take this into southeastern U.S. During the prescribed burning season coming up here, and apply this to aircraft that are doing plastic sphere dispensing operations, where they're actually dropping little balls out of the helicopter that are starting the prescribed fire. It's a relatively dangerous flight profile for the helicopters, so we want to provide up to the second location tracking of the helicopter's movements to the burn boss using this solution. One more thing that we've been working on is the fire area survey plugin. So it's a relatively common workflow on fires that are small enough where they don't have an aircraft assigned to map the fire, that the incident commander or someone on the fire has to physically hike, drive, or fly in a helicopter maybe around the edge of the fire to map out how big it is, capture that information as a polygon, and report it up to dispatch so we can know how big the fire was. Typically that workflow is done using Avenza right now. It works, but if you're not a federal customer, if you're a volunteer fire department, volunteer firefighter or someone like that, you're potentially paying up to $120 per year for access to that app. So we were interested in seeing if we could build that functionality into ATAC. We had PAR Government work on this for us. They actually were, I believe, able to reuse some code from some of the military runway survey plugins and build this plugin for us, which is the fire area survey. So with this plugin, you simply start tracing a shape out. You can use either your fingers to do it, hand jam it into ATAC, or you can actually use the GPS on the phone to drop a trail of breadcrumbs as you hike around the fire. Once you finish, you can tie the track that you just laid, or you can even combine multiple tracks into a polygon. Then you can see the acres of how many acres have burned. We can export that, share that to dispatch, or we can send it directly to other ATAC clients. So this is something we're really excited about. It's currently in beta. We're working through the paperwork to get it released out publicly into the Google Play Store and available by tac.gov as well. So stay tuned for that. So now we'll talk about some of the deeper pilot project deployments we did this year. Sean, do you want to say anything on this before I kind of dive into the Tamarack fire?
No, so I guess just what's important about this is all these fires, took a lot of upfront coordination. These guys these people are out there actively managing a wildfire incident. So public safety, dealing with everything that has to go along with that. And then here comes a group of nerds walking in with a lot of wires and computers and say, can we take over some spots and work on your fire? So on all the incidents that we went out, we had excellent buy-in from the local cooperators, the firefighters. Everybody was excellent hosts for us, and we accomplished what we needed to. What was very interesting is early on we had some hotshot crews and others that were basically like, Big Brother, go away, don't touch me, don't track me, whatever. The next fire we go out, we see them, and they're walking over saying, hey, can we get one of those tracking devices? So it was one of those build-as-you-go programs, and none of this would have been possible if we didn't have that local support, which it's critical for all this. You got to have the buy-in of the customers that you're trying to serve and help, and that was great. The final thing is some of these were kind of more formal pilots, so where we had a large group and a lot of infrastructure there. That's kind of your top three. The fires you see down below, the programs, those were kind of one-off opportunities that popped up, and because of Brad and the team that we pulled together, they were quickly able to respond to an opportunity and get out, and we were able to test as different devices in different scenarios through the summer.
And I should say the entries in red are ones where TAC was involved. So yeah, it was about June we brought everything online and were able to get out into the field. So the first fire that we're going to talk in depth about was the Tamarack fire. Before I get into that, though, just some general comments that we were receiving from folks. I think that it's important to pass along some of this feedback directly. Oftentimes things get lost in translation. So, one of the things that we found is that people are excited about this. There were some hotshot crews that weren't really excited about the Garmin InReach devices, but once they saw TAC and saw that they could see the information in the field, they were getting a little more excited. A big challenge for us was just, we didn't have the time to put on formal training, pull people out of the firefight to train them on TAC, so we were providing about 5 minutes of training total. So we were seeing some challenges in terms of people being able to understand the user interface and conduct some basic tasks in ATAC. Basically folks saying stuff that sometimes it provides too much complexity and too much information. I'm really excited to see if we notice an improvement in that feedback with the user interface change in 4.5 that's come out. I'm optimistic that will help. Hopefully we can continue to simplify the app and make it easier for folks to use with minimal training. The other thing we're hearing is that people are very excited to get access to ITAC. We have heard that about 80% of the installed base of government-owned smartphones in USDA and Department of Interior wildland firefighters or iOS devices. Folks are very reliant on those, partly because they're familiar with them, but partly because iOS has the AirDrop feature that allows you to send larger files, such as those maps that are produced once a day, directly between phones, even if you don't have any internet access. That's something that I've even heard folks say that they would rather keep using Avenza and have the AirDrop feature rather than have TAC and have access to the locations of other people in real time. So I think it's going to be really imperative to continue fostering ITAC, get it out there publicly, get AirDrop integrated with it, and I think we're going to see a real groundswell of interest in the product at that point. So getting into Tamarack, this was a fire that was right on the border of Northern California and Nevada. It's pretty close to the second fire we'll talk about, the Caldor fire that burned into the Lake Tahoe Basin. So we spent about a month in Carson City, Nevada this summer between those two fires. On Tamarack, we showed up late in July with an 8-person crew. We had some state of Colorado personnel, Sean and Washington office folks were there from the Forest Service, and then we were very fortunate to have the T&D module. It used to be the AFUE module. This is a group of firefighters from the Forest Service that are highly experienced, ex-hotshot, smoke jumper type individuals that are solely out there to do technology projects. So it was really great having them. They can speak the language of the hotshots and all the hardened wildland firefighters out there and get devices into hands and get training done. So that was really great. There's some statistics for you. In total, we deployed 66 inReach devices, 30 TAC phones, and then we had multiple BLM apparatus that had those satellite trackers on the fire.
So this is one of those policy things that came up, technology, we can track, right? But when you start talking to the ops guy, so you can see we have more inReach devices, the blue pie, part of the pie, than the orange, but a lot less percentage of the points. It's because those inReach devices were designed to transmit a location every 2 to 10 minutes, whereas the TAC device was
potentially up to every second or
right?
two.
So when you sit down with ops and plans, and you're like, okay, if I'm tracking a firefighter, or I'm tracking a piece of equipment, how often does that position need to report? BLM learned this lesson the hard way when they went out and deployed the 700 devices on their engines. Initially, they tracked every 30 seconds and captured all kinds of information about the engine going through that satellite connection. Then they got their bill and said, whoa, is this really worth the bang for the buck? And so they had to play back and forth with the repeating how much they were sending that information and how often they sent the information, what information they sent. So the same thing here is when you start looking at all these reports, going back to ops and saying, if I'm tracking a hotshot crew, how often do they need to report their location? If I'm tracking an engine, how often does it need to report of its location? So trying to get that type of information out, so when we build this program and we deploy these devices, they're meeting the needs or the requirement of the operations folk.
So yeah, another limitation, of course, with TAC was that we were relying solely on commercial cell service for this deployment. We know there are alternatives out there, and we're starting to test some of those, but at least operationally, we were using FirstNet on this fire. So we were looking to see, as we deployed, where we could have the best probability of success deploying TAC with FirstNet. So this is what you see when you look at the FirstNet website in the area of the fire. The fire was burning kind of right in this area. So this map on firstnet.com was pretty hard to interpret. It's kind of a mess. I don't know what the yellow color is there, but it sort of implies that there's some service kind of throughout the whole area where we're looking to respond to this with TAC. Look at the data a different way. This is a data set from the Federal Communications Commission that displays AT&T's 4G coverage. We can actually get the fire perimeter on this data. You start to see a little bit different picture. The state line right here, separating California and Nevada. On the Nevada side, we can see pretty good coverage purported to be there. On the California side, much spottier. Ultimately, we wanted to take it a step further, and I used a tool called cellmapper.net. It's a crowdsourced LTE mapping service where you have an app on your phone, and you're actually capturing the location of where your phone is getting bars of cellular service and what eNode B cell tower you're actually connecting to. So they're able to start mapping that out on the ground. Before the fire, as we were gearing up to respond to it, took a look at that. We can start to see where the actual towers are purported to be, and sure enough, they're pretty much all on that Nevada side of the border, not the California side. So when we decided to come to Tamarack and deploy, our strategy was to deploy the inReach devices with our field crews, so the actual boots on the ground, hand crew squads, engines, bulldozers, folks like that, and then focus TAC with our overhead that need to see all that intelligence in real time on where those crews are located. And then we also had some phones extra to give to our boots on the ground if they were on the Nevada side of the border. So engines and hand crews that were scheduled to work on that side, we would give them a TAC device as well. So here's the data that we got. So this is data pulled off the TAC server, split out all the vertices so we can see each report that came into the TAC server and mapped it out over the perimeter of the fire. So kind of a big spaghetti plot of data. An important thing was we did field TAC with airborne resources, air attack, as well as operations folks and hotshot superintendents that were getting recon flights in helicopters. So obviously, once you're up in the air, as Dave very well put it, you can get connectivity, and when you're down on the ground, you're much more reliant on the terrain and things like that. So went ahead and filtered out anybody that spent any length of time in the air. Unfortunately, even if it was just a hot shot that was on the ground 90% of the time and took a recon flight, I had to strip his data out entirely. But for folks that were solely on the ground, this is what the data looked like. So it gives you a little bit more clear picture of where TAC was functioning and where it wasn't. Again, we obviously purposely deployed primarily on the Nevada side of the border where we had good cell service. There's some WUI firefighting in there. You can see that there are some reports that were managed to trickle in on the California side as you get into the Sierra Nevada. It's a little more sparse. Then compare that to the green icons are handheld Garmin inReach devices. The blue icons are the BLM vehicle trackers. You can see, of course, with SATCOM, you have the advantage of being able to not rely on terrestrial coverage. So a little bit more complete coverage of the fire there. So for ADSB, we brought along 2 nodes. We set up one node at the incident command post, working with the comm staff to just jerry-rig our omnidirectional ADSB antenna up to one of the command repeaters. Pretty simple process. Did the same thing at another mountaintop site closer to the fire, where we set that up in addition to a pan-tilt zoom camera. So we were able to send that data to ADSB Exchange successfully using commercial LTE, integrate that in, and provide the ADSB tracks to firefighters. It was a one-off solution, so this is the kind of spaghetti bowl of cords and devices that made that work. We're working on streamlining that, making it easier to deploy. I think when we come to the southeast, we're hoping to bring that on carry-on luggage and deploy it that way. So something to look forward to there. Point that I really want to hit was the absolute joy that it was to work with data sync on this fire to push data out into the field. So as I said, every morning we get a new map of the fire that is provided by the incident mapping staff. We push that GeoPDF map into a data sync mission for the fire. So all of the phones that we handed out, they run the data sync plugin in addition to ATAC core, and they are subscribed to a mission that we manage. So we would push this base map along with the fire perimeter and all the incident mapping information out each morning. And then as the day went on, we have an aircraft called AirAttack 51. It's operated by the Forest Service, has a FLIR camera on it. They would come over the fire in the early afternoon and basically map out a second perimeter of what has burned. We would get that as a KMZ file at the command post, and we would add it to the data sync mission. And that would seamlessly push that KMZ file out into the field. That would either take effect immediately if the firefighter had LTE service and were connected to our TAC server, or if they were disconnected when they came back into cellular coverage, even if it was just for a couple seconds as they were cresting a ridge or something like that, they would connect up to the TAC server, synchronize with data sync, and get this new data. So the green here, this is mapped out by the AirAttack 51 platform. I believe the green is like the heat perimeter, and the red area are areas of intense heat activity. So what that did for us was early on, we arrived on the fire and it was still burning very actively and growing to the south. This is what the fire behavior looked like as we were driving around on that day. And when AirAttack 51 came over, we were able to map out the growth and push that out to folks in real time. And there was a situation on the south side of the fire where the field operations, the guy that's in charge of all firefighting strategy at the operational level, they were trying to determine a strategy on how to contain the fire on the south side. They had a couple hotshot crews to do that. Hotshots, sometimes they're referred to as the special operations of wildland fire. I think maybe the Marines is maybe a more fair term. I don't know, AJ, if you'd agree with me, but they are the ones that go in and get the hardest jobs and are the tip of the spear when it comes to the really hard work of containing these fires. And the situation we had was the hotshot crews, they wanted to execute a large burnout operation along a highway to contain this fire. that would remove all the fuel from the main fire and would contain it, but it would also make the fire significantly larger. Operations really wanted them to go direct and contain the fire where it was currently burning. They didn't know where the fire was, though. There's too much smoke. So with the data sync and the Air Attack 5.1 data, the field operations was able to convince the hotshot crews to attempt a direct containment strategy on the fire, and it ended up working. So down here on the south, along the south edge of this green polygon, that's the highway they would have burned off of. And then in red, you can see where the fire ended up being. And so you do a little GIS wizardry, subtract those two areas, and we basically saved about 16,000 acres from burning based on the data that was provided to field operations and to these hotshot crew superintendents in real time using TAC. I mean, it's always hard to say what would have happened or wouldn't have happened, but I think in this case we have a pretty strong case to be made that that real-time intelligence from TAC made a concrete difference in how we fought this fire. So to kind of confirm that, here's some raw feedback from the field operations. I think he was actually the field operations trainee on this fire. So obviously some positive stuff about being able to see resources in real time. I think a key thing here is that he stated that this being able to see where folks were, it really cut down on the level of communication that was required over the radio. You think about if you're involved in public safety, how much time you spend on the radio just trying to figure out where other people are. With TAC, we're able to cut down on a lot of that. That frees that radio traffic up for more urgent matters. Everything from being able to see the ADSB locations of aircraft. Again, the Air Attack 5.1 perimeter was outstanding for situational awareness. And then some dings on us. Being reliant on cell service is a challenge. And then, with that limited training, we were able to provide some functions eluded him. So the second deployment that I'm talking about today was the Caldor fire. This was a little later in the summer of 2021, and this was the big fire that burned into the Lake Tahoe Basin. Started in the foothills of the Sierra, outside of Sacramento, and made it all the way up into the Tahoe Basin. We deployed on the east side of the fire. This fire was so large it had 2 incident management teams assigned to it. So we were with California Incident Management Team 4 that was just managing the fire in the Tahoe Basin. With this one, we were a little more resource limited. We had 4 crew members instead of 8. But as you can see, we were still able to get quite a few devices out, quite a few in-reach devices. And then you'll actually see even more TAC devices here. This incident management team had their own cache of Android phones. Fortunately, they had some familiarity with TAC already, and we were able to really seamlessly integrate them in. So you're seeing both their team devices that they have on a standing basis, as well as the cache of phones that we brought with us. So in addition to deploying the in-reach devices and TAC devices purely for resource tracking, we also did some more kind of advanced tests to build off our successes on the Tamarack fire, specifically testing, getting real-time data from aircraft, as well as mesh networking radios. So the aircraft that we worked with on this Caldor fire was the DRTI, or Distributed Real-Time Infrared Aircraft. It's a National Guard RC-26 aircraft. This program has been around for a number of years, and kind of the gist of it is that they use a rover downlink to bring real-time video from the aircraft down to the ground, and they have JTACs, or the military combat air controllers, from the National Guard Bureau. They are on the ground receiving that video with the rover, and they're able to display it for fire managers to see. They used to do that, I think, in Falcon View, and now they do it in ATAC, which is awesome. The challenge with that is that they're only able to display that information if they have the rover radio and have a link to the aircraft. So what we wanted to test was, could we break that data out of the rover and actually get it out over the internet so that everybody can see it, even if you're not standing next to a JTAC. So the workflow that we used to do that, a little bit of a family circus here, but from the aircraft downlinks to the rover, and then typically this is where it would end. It would plug straight into a tablet or into a computer, TV screen, something like that, and you would see the data right there. What we did is we had a local area network stood up with Ethernet, and then we had a Starlink dish as our backhaul. And one of the reasons we used this was to test this ability, even if we were in an area that had absolutely no cell service or any other type of internet connectivity, could we use Starlink as a backhaul solution? And then we had an ATAC tablet running the UAS tool. So this is a bit unconventional use of the UAS tool. But basically, we took in the multicasted video feed from the TAC rover, entered it into the UAS tool, and then using the rebroadcast function in the UAS tool, we sent it to a Jaguar server that the Forest Service had stood up as part of the Dingle Act. So that handles the full motion video, which is basically the video with spatial metadata. We also wanted to make it seamless and easy for TAC users out on the fire to connect to this video. So the UAS tool also sends COT data for the aircraft where it's looking and the Jaguar URL to view the video to our EGP TAC server. So that's where these two lines are. That all comes together on the TAC client. So it sounds like a lot, but basically the end result is that we were successful in sending this data over Starlink to the cloud and back out through commercial LTE. And so if you were a firefighter, even you didn't have a rover radio, you're just out connected over FirstNet. When this DRTI aircraft was flying, you would see the blue icon appear on the map. You tap on that, you get the radial menu. There's a play button in that. You hit the play button, and you're actually connecting to the U.S. Forest Service Jaguar server, seeing the full motion video feed as shown here on the right. So pretty seamless process for our end user, and something that we're really excited to test and demonstrate on this fire. The other thing that we were looking at was mesh radios. So again, for operational, actually firefighter use on this Caldor fire, we used FirstNet LTE, and that was pretty successful. Tahoe Basin, much more of a urbanized environment, so we had pretty good cell service throughout the incident. But we wanted to test, how would this work if we had, absolutely no LTE service and we had to come up with alternatives. So we tested a couple different radios on this fire, the GoTenna Pro X and the Beartooth Mark II. We tested those together as kind of a low-end test for just position sharing. And then we tested the Silvus 4200 as a kind of higher bandwidth radio that might potentially be capable of video distribution and map sharing and stuff like that. So for this test, we didn't actually see if the radios could form a large mesh. We were just interested in the maximum range possible between two radios. So for that, we basically tested to see between a command repeater that's stationary and a vehicle that's roving around the fire. And then at the command repeater, we again had Starlink as our backhaul. And that basically looked like phones that were paired to these mesh radios, and then they were connected to the EGP TAC server over Starlink. So the idea there is if we were in the Frank Church wilderness area or some very remote fire where there's no cell service, could we use Starlink to backhaul the information out so that folks in dispatch and further up the chain of command can see what's going on? So this is what that looked like. It was a pretty simple setup, but we had a tripod, fiber taped the radios to the top of the tripod. Further down, we had the phones that were paired to the mesh radios over Bluetooth, and then they were connected solely to the internet over Wi-Fi to our Starlink device that's just off camera. It's always tricky to test radios because you can always come up with a scenario where the radio will work perfectly, and you can always come up with a scenario where the radio will fail every time. So we wanted to be somewhat realistic, so we set this up at a drop point where you would have supplies being exchanged and firefighters staging on an incident. And we set this up purposely in a spot where it had good coverage. It was high up above a valley that we wanted to test coverage in, but we purposely set it back from the edge of the cliff so that there wouldn't be perfect line of sight to the entire valley. So we wanted to test the ability for these radio systems to diffract a little bit over the lip of this cliff and reach the repeater. So what we did is we had the command repeater right here, the orange radio tower icon, and then we had two trucks driving around sequentially. So we had one truck that headed to the east, and this was basically rolling terrains. There was no height advantage from the repeater to the roving truck. And then we also sent our trucks down into this valley. And this was about a 500 vertical foot drop between the repeater and the valley where we were roving around. So you can see the actual track of the two vehicles here in red and blue. And then the dots are locations where positions were successfully transmitted over the mesh radios out through Starlink to our TAC server. So the circles are where the GoTenna Pro X was successful, and the diamonds are where the Beartooth radio was successful. basically the Beartooth, it squawks out your location every 10 seconds. The GoTenna Pro X was squawking out the location every 30 seconds. And I haven't been able to figure out a way to do a quantitative analysis on this, but I would say, from my perspective, roughly both systems were about equally successful. The GoTenna was probably a little, higher probability of success, but I think, Beartooth, by broadcasting out more frequently, also had an advantage there. So ultimately, we're pretty pleased by this. Up on this north side of the valley in particular, we didn't have great line of sight, and we were out of the official view shed that you can see in pink here, and the radios were still able to function successfully. Later on, we repeated a test with the Silvus radio. With this one, we just sent one truck out and roved around, and we actually stopped at the black to orange dots. We stopped, waited about 60 seconds to see if the radios could connect between the command repeater and the roving vehicle, and then we would run a speed test if we did get a successful connection. So you're seeing in yellow, we had a quicker speed test, and then down in orange here, these were slower speed tests, in some cases down to about dial-up internet speed, actually running a commercial speed test. We also left the Silvus radio running when we were driving between spots, and that's what these red squares are. These are all locations that were just PLI being broadcast successfully from the ATAC device over Silvus radio to the command repeater, then out by Starlink. So I think the end result here was that the Silvus radio was much more sensitive to line of sight, which makes sense. It's a much higher frequency. So, probably something that we're going to look more at aircraft-based applications and stuff like that for in the future. So that's the two deployments that we did. I think I'm going to turn it back over to Sean to kind of close us out and discuss the recommendations.
Thanks, Brad. So like I was saying earlier, we're not giving a technology recommendation up to Congress or our decision leaders. A lot of our recommendations are based on interoperability, recognizing that TAC is, a lot of people like to use the idea of a golf bag. So you got all your different clubs in there, you got your putter and you got your driver. You can't use your driver everywhere, you can't use your putter everywhere. We recognize that there's different tools for different things. And so TAC is one of our highly recommended tools. Very excited to see everything that we saw this week with some of the Esri integration. We are Esri shops, we're land management agencies. All of our data is built into GIS-based systems, so being able to interface with that when we're fighting fires is critical for us. We recognize, like I said earlier, 608 agencies, so we got to have a governance framework on how we roll this out. We can't just go out to a fire and start handing out devices. One of the big feedbacks we got from all of our divisions and line folks was I got to be able to tell the difference between my resources quickly. The channels is a good idea, the color's a good idea, but they want to be able to look at a dot and say that's a Type 6 engine or that's a Type 3 engine. You want to be able to see that immediately, especially when they're in the heat of the battle. We have the National Wildfire Coordination Group, which I was talking to you earlier, is how we're successful for our common standards. So we want to be able to get the standards in place as we're building the technology. So when we roll this out, it's all based on standards for use across the country. Which one's forward? Big guy. All right. Again, we know this data is going to be very valuable to research, and we'll change our tactics and we'll change the way that we fight fires. So we want to, as we capture the data, we want to be able to have it readily available to our research staff and our operations people to be able to run scenarios and drills and training, but also being able to look at it from historical analysis and perspective. One of the ideas that's immediately come up is, we start finding areas where we're best practices. Dozer lines work typically in this terrain, or hand lines will work well in these type of fire scenarios. Being able to track where that type of information is being put in, and then being able to play those scenarios back over and over, you start learning. That's kind of what AI is. You start learning where we're being more effective with our firefighting. Brad just talked to you about last mile connectivity. The story I tell everybody is I live in Boise, Idaho. I go to Missoula, Montana. It's an 8-hour drive, and I've done that drive a lot. In that 8-hour drive, I have 45 minutes of connectivity, and there's a lot of fire between Boise and there. So how can we improve on our last mile connectivity? That's critical for all this success. And then one of the big things out of all this is the recognition from our leadership that technology's changing, technology's evolving, firefighting's changing, firefighting's evolving. So we built the foundation for pilot programs and how you can go out and do it. And our leadership, we're selling to them that you have to continue to do this. You can't just do pilots when Congress tells you. You have to be more proactive, and we have to be more proactive as a group in evaluating and bringing technologies in. So these are all recommendations we've taken forward. I'll let the powers to be and the fire directors and the secretaries approve them or disapprove them or tell us what to do. But this is what our recommendations are from the work that we've done this summer. And like Brad said, we're not done. We're hoping to get down to the southeast this year and do some work on the prescribed and wildfire activity that'll be coming up in that area here shortly. So you talk about your future TAC.
Yeah. So zeroing in on TAC a little bit, we are going to continue to work on testing and evaluating some things with TAC server for wildland fire. A challenge for us has been working with the federal IT bureaucracy, and we've unfortunately had some things that have been disapproved for us to test at the federal level. Fortunately, we've been able to stand up a state level server that will sort of allow us to test out and vet some of these ideas. So specifically, we have a Colorado Wildland Fire TAC server, and that is integrated with a large LDAP database that we have about 1,200 users in. So we're going to test using that server how we can integrate with things like channels, individual authentication and security, and then how to federate that data from our Colorado server back up to the federal EGP server. We're also going to be working on a report for the Dingalac team on how to achieve enterprise scale with TAC server, having a lot of follow-up conversations with some of the folks that have been presenting this week on how to find the best practices to do that. And then we are looking to continue the pilot project capability that we have right now with our EGP TAC server, at least through June of next year, likely another year beyond that, and then looking at potential additional enhancements as things are upgraded in TAC server and as we're able to fund them at that pilot project level. And then I think, do you want to finish up the last slide to kind of wrap things up?
Yeah, I think, like I said earlier, TAC's proven itself as a capability. It's not the panacea, it's not the silver bullet for our tracking location needs. We do know that it's gonna be critical. It's important for all of us to move forward. One part of the Dingalac that we really, as Brad kind of alluded to, is integration more with the full motion video and real-time imagery. Really need to expand upon that. The big part about TAC and all this is the logistics tail. Everything that we talked about here is going to require a significant logistics tail in the back end. We can go out and put devices and hand devices to our hot truck crews and our engines and kind of our standing firefighting crews. But when you have like these Caldor fires, you can have 5,000 people show up, and that's what we term as our militia. And those folks are, the ops chief on the Type 1 team, he was a rangeland specialist. So he managed cattle on BLM land in Nevada. So he doesn't do fire for his regular job, but he's going to show up and say, I need a TAC device. So how do we provision a TAC device, give it to him while he's fighting fires, and then bring it back and give it to somebody else? So things like that. And then continuing to build partnerships. So met a lot of excellent people this week. We saw several great public safety TAC presentations before us, bringing together that public safety community. And they're working concurrently with the military side. So we got Civ TAC and the military TAC. How can we all work better together and leverage those partnerships?
Awesome. Well, with that, I think we'll take questions. You have our emails if you want to follow up with us. Most of what you saw today are documented as well in a story map, which is basically a blog with a bunch of map tiles on it. So feel free to scan the QR code there if you'd like to check it out. It's also linked to our presentation at tac.gov. So with that, happy to take any questions that you have.
Any questions?
No idea.
Brad, Genius work with Starlink. I just want to know, what was the latency to your TAC clients with Starlink?
So I wish I had a screenshot of it. We did a number of just commercial speed tests off the Wi-Fi from Starlink. If memory serves, it's about 50 to 60 milliseconds. So that is pretty favorably comparable to 4G LTE or even some of the early 5G implementations out there. Certainly the upshot is that a TAC client performed normally over Starlink, same as you would see on any other type of internet connection.
Any other questions? Okay, thank you, gentlemen.